Hey developers, welcome to Devcovery. Today, we're bringing you the hottest open source projects trending on GitHub, so you don't miss any tech developments worth your attention.
Today, we're taking a deep dive into a trending project on GitHub, lingbot-map, a feed-forward, three-dimensional foundation model that reconstructs scenes from streaming data. This project is exploding in popularity because it offers a new, incredibly efficient way for machines to perceive and map their environment in real time. A huge step forward for robotics and augmented reality. What if you could build a detailed 3D model of a room, or even an entire city block, just by walking around with your phone? For years, that kind of task required specialized hardware or hours of offline processing. But a new project is challenging that assumption. It's turning video streams into 3D maps, all in real time. The project is called lingbot-map. It's a 3D foundation model from the Robbyant team, designed specifically for streaming scene reconstruction. The goal? To create 3D environments directly from live video feeds. And it's getting a lot of attention on GitHub, with over 8,200 stars and counting. In fact, it gained more than 370 of those in just a single day. This explosion of interest from developers and researchers suggests a major shift in how we think about real-time spatial computing, and with over 800 forks, the community is clearly engaged. So, what problem is lingbot-map solving? Traditional three-dimensional reconstruction methods have always faced a tough trade-off. On one hand, you can have precision, but it's slow and often requires offline processing. On the other, you can have speed, but you risk drift, where small errors pile up and distort the final map over time. This makes them a poor fit for real-time applications like robotics or augmented reality. Lingbot-map approaches this differently. Instead of slow iterative optimization, it uses a single feed-forward neural network. This network learns to do everything at once: locate the camera, build the geometry, and correct for drift, all in a single pass, straight from the video stream. The magic behind lingbot-map is its geometric context transformer, or GCT. You can think of it as a highly specialized brain just for spatial reasoning. Unlike older methods that handle tasks separately, the GCT unifies camera tracking, geometry creation, and long-term consistency into one single streamable process. Now, a huge challenge for any transformer working with long video sequences is memory. As more frames come in, the model's memory, its KV cache, gets bigger and bigger, which slows everything down. To solve this, lingbot-map borrows a clever technique from large language models called paged KV cache attention, using the flash-infer library. This acts like an intelligent memory manager, organizing past information into efficient, separate pages. This powerful idea prevents bottlenecks and allows the model to process sequences of over 10,000 frames at around 20 frames per second, a feat that was previously out of reach for streaming models. So, what does this mean in the real world? The applications are immediate and incredibly practical. A robotics researcher could use lingbot-map to let a drone build a 3D map of its surroundings while it's in the air. An augmented reality developer could walk through an office with their phone to create a digital twin for an AR experience. And the barrier to entry is surprisingly low. With a standard GPU and a video file, any developer can run the interactive demo and watch a 3D point cloud build itself right in their browser. The project even includes an offline pipeline to create high-quality fly-through videos from these newly built scenes. The community reception has been overwhelmingly positive. Developers are praising its ability to generate stable three-dimensional scenes from just a simple RGB video, calling it a breakthrough for robotics and embodied AI. Its open-source nature and low barrier to entry are also frequently mentioned as major pluses. The main concerns are forward-looking. People are asking how it performs in dynamic scenes with moving objects, and they want to see more direct comparisons against established methods like Gaussian splatting or traditional SLAM. But despite the innovation, the project does face some real-world challenges. For one, its performance is tied to a very specific hardware and software stack, like NVIDIA GPUs and libraries such as flash-infer. This could make deployment tricky, and since it's a learning-based model, its robustness is limited by its training data. it might struggle with scenes that are drastically different from what it was trained on. Finally, that fast, feed-forward design might not achieve the same pinpoint global accuracy as traditional methods that optimize the entire map, especially on very long paths without clear loop closures. Ultimately, lingbot-map represents a paradigm shift. It moves 3D reconstruction away from slow, iterative optimization and toward fast, streaming inference. It's making real-time, large-scale 3D mapping accessible, bridging the gap between academic research and practical use in robotics, AR, and more. And that is why it's a project worth watching.
That's all for today's Devcovery. We hope these GitHub trending projects spark some inspiration for your development work. You can find all the repos mentioned in the description below. If you enjoyed this episode, don't forget to subscribe to our channel. See you tomorrow at the same time.